All right, welcome to part B of particle motion for calculus with Mr. Robeson. All right, so now we're going to look at particle motion without gravity. So they're just going to give us a function, and that's how it's moving. Maybe it's moving side to side, maybe it's moving up and down. We do most of the things the exact same way, it doesn't matter. All right, then we'll look at distance traveled versus displacement. Those are two different things that we need to keep straight in our head. All right, so usually if we're going side to side, like if it's moving along the x-axis, we'll use x of t for our function. So we'll be moving left to right. If we're moving to the right, that's positive. If we're moving to the left, we usually call that negative. Right, if we're moving up and down, we usually use y or h when we're using gravity. All right, positive would be up, negative would be down. So if we're talking about x, we're going side to side here, then its derivative is still the velocity. If the derivative is positive, that means it is going to the right. If the derivative is negative, that means it's going to the left. If the derivative is 0, that means it has stopped. All right? So like it'll move to the right, say, and then it'll stop, and then it'll come back to the left, and then it'll stop, and then maybe it'll come back to the right. Who knows? Right? But that's what we can do, is we're moving back and forth side to side kind of thing. All right, the acceleration, still the second derivative. So if we take the second derivative of the position, we're getting acceleration. And now we're talking about accelerating from side to side. All right, this happens a lot with a spring. They go back and forth side to side like that a lot. All right, so particle motion examples. So it's the same kind of stuff we were just doing before, except now we're moving side to side. So a particle moves along the x-axis with the position function, x of t, at any time given by, there's our position function, and we're time greater than or equal to 0, so negative answers are not going to count. What's the particle's instantaneous velocity at t equals 2? Well, that's the derivative at 2. So we want to know what's the derivative. Well, it's 3t squared minus 8t plus 3. So the velocity at 2 is 3 times 2 squared minus 8 times 2 plus 3. So 4 times 3 is 12 minus 16 plus 3, so 15 minus 16 is going to be negative 1. All right, we don't have units. All right, so they didn't tell us what units we're using, so it'd be units per second, I guess, would be our time. But again, they didn't even tell us what our time was, so just negative 1 is fine. But that means it's going to be moving to the left. Negative velocity, so it's going to the left, negative direction. What's the particle's acceleration at t equals 2? Well, now we want the second derivative at 2. So the second derivative, in terms of t, so we're taking the derivative of this guy right here, is 6t minus 8. So now we still have t's. That happens. So now, again, we're just plugging in 2. We get 12 minus 8 is 4. Positive. So we're accelerating in towards the right. All right, so what direction is the particle's motion at t equals 2? Well, we're going left, because the velocity is negative. At time 2, is the particle speed increasing, decreasing, or neither? So once the acceleration is positive, the velocity is negative. So a of t is greater than 0, v of t is less than 0. In fact, I can plug in 2 instead of writing t here. Since they have different signs, that means we are slowing down. So the speed is decreasing. All right, so different signs means they're fighting against each other, it's slowing down. What's the average velocity from t equals 0 to t equals 4? Well, that's just going to be x of 4, the position at 4, minus the position at 0, over 4 minus 0. All right, so we're going to get 4 to the third minus 4 times 4 squared plus 3 times 4 minus 2 minus, if we plug in 0, we're just going to get that negative 2 at the end. Everything else is 0. All over 4. These two cancel out. These two cancel out. We get 12 over 4, which is 3. So the average velocity is positive 3, so that would mean we're going to the right at 3 units per whatever time. Particle's acceleration, positive. All right, so we go back to our acceleration. X double prime equals 6t minus 8. We want to know when that's positive, so we set it equal to 0. We subtract the 8, we get 6t equals 8. Divide by 6, we get 8 over 6. which is 1.33333, or 1 1/3. 1 1/3. All right, so when is it positive? Well, if we plug in a number bigger than that, it's positive. If we plug in a number less than that, it's negative. Again, we're starting at 0. We're going forever. This is our second derivative, our acceleration. So the answer would be from 1 1/3 to infinity. All right, so there's some particle motion going side to side. And positive here would mean, again, to the right. Tired of looking at red. All right, so distance versus displacement. So displacement is the easy one. Displacement is just the position at the end minus the position at the beginning. Like, what's the change in the position from when we started to when we ended? So like if we're going side to side, maybe we start here, we go this way, then we go this way, then we go this way. We want to know how far has it traveled from here to here. That is the displacement. Right. If we're doing distance and we got the same sort of thing, we start here, we go this way, then we go back this way, then we go back this way. We've got to add up all this distance. So we got to go to there, then we got to add up to there, then we got to add up to there. So we got one distance, then we got a second distance, and then we got a third distance, and we want to add them. All right, so what we have to do is we have to figure out when the velocity equals 0. So like here, v equals 0. Here, where it stops and turns around, v equals 0. So we have to break it up. So we got to break up the interval every time that v equals 0. And then, just to make it easy on ourselves, we do the absolute value over each of those little intervals. All right, because some of these intervals will be going positive, some of these intervals the distance will be negative, but we just take the absolute value of all of them because we get the total distance it travels. This distance is a positive length, as far as we care. All right, so distance is the harder one. All right, we got to do the derivative, set it equal to 0, and then find the difference in the position for each one of those times it equals 0. Displacement, how has it changed? And displacement could be positive or negative. Like maybe it's gone backwards some, maybe it's gone forward, maybe it's gone to the right, maybe it's gone to the left. All right, so more on this. So we've got our function here. We're moving along the y-axis, so we're going up and down. So up will be positive, down will be negative. Find the object's acceleration each time the velocity is 0. Ooh, tricky. So we want to know when is the velocity equal 0. So we want to take the derivative. 3t squared minus 12t plus 9 and set that equal to 0. And factor out a 3. Let's see if we can factor that. T minus 3 and t minus 1. So it looks like we're getting t equals 3 and t equals 1. And now we want to find the acceleration. So we want to take the second derivative. So the derivative of this guy is 6t minus 12. And now plug in each of those. So the acceleration at 3 is 18 minus 12 is 6. The acceleration at 1, 6 minus 12 is negative 6. That wasn't so bad, but again, lots of stuff to do there. Find the object's speed each time the acceleration is 0. So when you want to know when is the acceleration, which is given by 6t minus 12 equal to 0. Well, if we solve that, we get t equals 2. Now we want to know the speed. So we find the velocity there first, and then we take the absolute value of it. So the velocity there is going to be, this might be easier to plug in here, 3 times 2 minus 3 times 2 minus 1. So negative 1, 1. So we're getting negative 3. But that's the absolute value of negative 3, so we get that the velocity, or the speed, is positive 3. What's the average velocity from 2 to 5? Well, that's the position at 5 minus the position at 2 over 5 minus 2. So we're getting 3 on the bottom. Position at 5, we've got to plug in there, so we get 5 cubed minus 6 times 5 squared plus 9 times 5 minus, and then we plug in 2, so we're getting 2 cubed minus 6 times 2 squared is 4, plus 9 times 2 is 18. I'll save you the trouble, but yeah, just working that out is just throwing stuff in the calculator, and that gives us our average velocity between 2 and 5. Is the object speeding up or slowing down at t equals 4? So we want to know what's the velocity at 4, and we want to know what's the acceleration at 4, and then we want to see their signs. How do their signs compare? So the velocity at 4, here's the velocity function. Actually, here's the simplified factored velocity function, 3 times that right there. So we get 3 times 4 minus 3 times 4 minus 1, which is easier for me to work this out. We could also plug in here. That would work too. All right, but this is 1 times 3 is 9. The acceleration function is right there. So we get 6 times 4 minus 12. So that's 24 minus 12 is 12. They are both positive. All right, 9 is greater than 0, 12 is greater than 0. So that means we are speeding up. They have the same sign, so we're speeding up. All right, if you're doing this on the AP exam, that's what we're looking for. You want to state that they're both positive, so it's speeding up. If they had different signs, it'd be slowing down. What's the total distance traveled? All right, so distance, that was the easy one. Actually, say I take it back. Displacement was the easy one. Distance was the hard one. Distance, all right, yeah, distance, it stops at 3 and 1. So we want to do the distance from 0 to 1, and then we want to do the distance from 1 to 3, and then we want to go from 3 to 10. So we've got to break it up into those 3 parts. So we get y of 1 minus y of 0, absolute value, plus y of 3 minus y of 1, absolute value, plus y of 10 minus y of 3, absolute value. All right, the reason we're doing absolute value because at least one of these is going to be negative. At some point it's going to be going down instead of up, but that still counts for a distance that it's traveling. So y of 1, if we plug in 1 here, we get 1 minus 6 plus 9 is, let's see, 10 minus 6 is 4. So y of 1 is 4. If we plug in 0, we get 0. So let's see, that's also going to be 4. Y of 3, we get 27 minus, it's going to be 2 times 27, so minus 54 plus 3 times 9 is another 27. We get 0. Oh, that's interesting. 0. 0. And y of 10, I don't know if I have room here, but I'll do it down here. So we get 10 to the third minus 6 times 10 squared, so it's 100, plus 9 times 10 is 90. So we get 1,000 minus 600, on top of 0 there, plus 90, so that's going to be 490. So most of it's coming from this end section here, 490. So we get 4, absolute value of that is 4, absolute value of that is 4, absolute value of that is 490. So we get 498 as our total distance traveled. All right, next up, displacement. Displacement's the easy one. We just want to know what's the position in the end minus the position in the beginning. How has it changed from the end to or from the beginning to the end? So y of 10 we found was 490. Y of 0 we said was 0. So the displacement is 490. In other words, we've moved 490 to the right from 0 to 10 times 0 times 10. This one we've gone back and forth. Like we went 4 over, we went 4 back. I guess 4 back to there, and then we went 490 over there. Another example. Actually, no, continued on the same example. I just moved more onto the next page. Determine the open intervals where the object has positive acceleration. So let's see, the first derivative we said was 3t squared minus 6t plus 9, 12t, not 6t. The second derivative we said was 6t minus 12. So positive acceleration is when that's greater than 0. So we would say 6t minus 12 equals 0, t equals 2. And we're starting at 0 and going forward. We've got 6t minus 12 is negative here, positive there. So that means our second derivative is negative positive, which means our function has negative acceleration here, positive acceleration there. It's not really a symbol for that. but we're looking for positive, so the answer would be from 2 to infinity. We could also write it like this, 2 to infinity like that. Either way is fine. Determine the intervals where the velocity is increasing. All right, so now we're looking back at this guy. All right, we did have that factored before. That was 3 times t minus 3 and t minus 1, if I remember correctly. Go back and look. Yep, minus 3 minus 1. All right, and so that equaled 0 at 3 and 1. So we can look 1, 3, and we start at 0. We've got factors of t minus 3, t minus 1, and 3. We can leave off the 3, it's always positive. So we got negative, negative, positive, negative, positive, positive. So that means the derivative is positive, negative, positive. So that means it's going to be increasing here and here. So from 0 to 1 and from 3 to infinity like that. Or we can say 0 to 1 and 3 to infinity like that. Open intervals or closed is fine as long as it's open on infinity. Determine the intervals where the object is speeding up. All right, so now we need to have the same sign. So they either need to both be positive or both be negative. So here's the sign right here for acceleration. It's negative from 0 to 2. Well, this is positive from 0 to 1, so they're different from there. But then from 1 to 2, like 2 would be right there, it's going to be negative in here. So they're both negative. So they're both negative from 1 to 2. So that means we're speeding up. All right. Then at 2, this switches to positive, and this guy's still negative. But then at 3, this one switches, the velocity here switches to positive. The acceleration is positive. So they are both positive from 3 to infinity. So then it'll keep speeding up there too. So from 1 to 2 and then from 3 to infinity. So it's not increasing, or it's not speeding up from 2 to 3, and it's not speeding up from 0 to 1. Determine the interval where the object is slowing down. Well, those are the other intervals, so that's where we have different signs. So it'd be from 0 to 1 and from 2 to 3. All right, so that is a little bit of speeding up, slowing down, distance traveled, displacement, and all that sort of fun stuff.